So this is a review of what we did on Monday. Again, if you weren't here Monday, you're definitely going to want to get the notes that you missed. And this actually, we were working on this last week as well. So rules for exponents. We took some great notes in our packet on exponents that said that if we're multiplying two things, what do we do to the exponents? Well, I'm going to do that 5 and that 3. I'm going to add them. So we're going to end up with x to the 8. Now this 2 over here is just going to stay in our answer. So our final answer would just be 2x to the 8. All right, number 2 is a little bit trickier than some of the problems that we did. Let me walk you through this. I'm going to show you the steps that I would do to solve number 2. All right, so I would go ahead and rearrange this. I have 1, 2, 3, 4, 5, 6 things that are being multiplied together. And you can multiply numbers in any order that you want to. So I'm going to rearrange this and group things that are similar together. Like this 3 and this 6 are not variables. I'm going to put those together. 3 times 6. I'll put that at the beginning. And then I've got a couple of things with x's. I've got x to the 2nd here, and I've got x to the 4th here. I'm going to stick those together also. And then I got a couple things with y's here. I got y to the 4th, and then just a plain old y, and I'm going to put those together. So all I've done in that first step is just rearrange things. So my x's are together, my y's are together, and any coefficients that I have, those are the numbers out in front, those are together as well. I'm going to do one more thing here. Everything has an exponent, including this y here. What is the exponent if it's not written? 1. Let's go ahead and write that in. I encourage you to do that. It's going to keep you from making some mistakes. So let's write our final answer now. We'll just go through piece by piece. This 3 times 6, that's a coefficient, so we just multiply, just like you normally would. 3 times 6 is 18, so 18 should be on our final answer. Then I've got my x to the 2nd times x to the 4th. I'm multiplying those, so the exponents are going to add. So 2 plus 4 is 6. And then I got y to the 4th times y to the 1st. Again, I'm multiplying those two things together, so the exponents are going to add. 4 plus 1 is 5. So final answer would be 18, x to the 6th, y to the 5th. This was a little bit higher level than what we've done before. So if you struggled at all, if you didn't get that answer, that's just fine. Let me know, though, does anybody have any questions about how we got that final answer? Are we feeling pretty okay about that? So if you see complicated stuff like this, where there's a whole bunch of different numbers and letters, my strategy is to group things together first and then just follow your rules. All right, I gave you a hint for number 3 as you were working. That 4 and 6, those are coefficients. So we're just going to do what we would normally do with a fraction of 4 over 6, which is reduce it. We can divide both of those by 2 and we get 2 over 3. Now, I don't want to write out 15 x's and 21 x's and start canceling them out. But if I did, how many would I have left over? I would have 6 left over. And I heard a negative 6. I'm going to come back to that in a second. But I would definitely have 6 left over. Would the 6 leftover x's be on the top or the bottom? They would be on the bottom. So I'm going to write x to the 6th on the bottom. Now, I really like what I heard just a second ago. I heard a couple of people say negative 6. So I'm going to go back to my 2 over 3. Here's another way we could do this. So 2 over 3. So if you said negative 6, you must have been thinking the rule is subtract, right? 15 minus 21 is negative 6. Yeah, that's what both of you were thinking. So that would be x to the negative 6, right? And then we would go one step further. What happens when we have a negative exponent? We move it to the other side of the fraction. So right now, it's kind of sitting at the top. I would move it down to the bottom. I would still end up getting that same answer, wouldn't I? So a couple different ways you can think about that problem and still come up with the correct answer. Number 4 is a little bit trickier as well. Let's see if we got the first step right. Did you guys take that x to the -2 and pull it downstairs? And did you take this y to the -5 and bring it upstairs? So your first step probably would look like this. I'm going to write what was there originally. The y to the 3rd was upstairs already. The x to the 4 was downstairs already. But we took this x to the -2 because it had a negative exponent. And we moved it down to the bottom. So I'm going to put that x to the 2nd on the bottom. Remember, when we move it, it loses the negative on the exponent. This y to the -5th is going to pop up top, but it's going to become y to the +5th. Now we can actually go one step further with this. Since these y's match, we can combine these together so that I just have a single y here. What should I do with the 3 and the 5? These are being multiplied, so we're going to add them. 3 plus 5 is 8. And since these are both x's, we can combine those together also. And x to the 4th times x to the 2nd, we should add those as well. 4 plus 2 is 6. I got one final question before we get into our new stuff. We have a rule that says when we have exponents in the top and bottom of a fraction, we subtract them. But we're not going to do that for this particular problem. Because why? Why can't I do 8 minus 6 and get an exponent of 2? Why would I not do that for this fraction? Anybody know? Because the variables are different. Exactly right. So if these had both been x's, then I would do exactly that. I would go 8 minus 6 is 2, and I would have x to the 2nd. But since the variables are different, we cannot do that. So we can't combine things unless the variables are different. These are called the base of the exponent. The big number on the bottom is called the base. And in order to do any of these rules that we wrote in our packet, the bases have to be the same. They have to both be x's or both be y's. So we're just going to have to leave this like this. This will be our final answer. All right. Can you guys show me on your thumb meter how you're feeling about exponents right now? My guess is that we're kind of in this range here. Looks like most of us are. We're going to be practicing a bunch of exponents on Friday. So if you've still got some questions, if you got some of these wrong, and I'll tell you that I threw a couple difficult problems at you. 2 and 4 especially are at a higher level than you would have seen in your homework or in class. So if you struggled on those two, don't worry about it. We're going to practice it a bunch on Friday, get you really good and comfortable with it. Okay. So we're going to move on. And again, we're skipping a couple sections. We're starting on 3.2.4 today. And our big topic for today is products and sums. And I bet you've heard those vocab terms before. What do you think of when you hear the word products? Do you think of add, subtract, multiply, or divide? Product, when we find a product, we're multiplying. And what do you think of when you hear the word sum? Add, subtract, multiply, or divide? Sum is adding. I want you to keep that in mind because sometimes my students aren't sure if they're looking at a product or a sum. The easy way to tell is check and see. Do you have two things multiplying? If so, that's a product. You have a bunch of stuff being added together. If so, that's a sum. If I get you guys to turn in your books to page 115, we're going to look at number 64 today to start off with. And we're going to do a couple examples together. And I'm going to ask you guys to do a couple on your own. Next to number 64 in your notes, I want you to write the word distribute. Distribute. How many of you have heard of distributing in math? How many of you have heard that word before? Couple. Okay, so most people know, but a couple of you have. And when you distribute, you kind of remember doing like the little rainbow arcs above the thing. Is that what you think of when you think of distribute? Okay, so I'm going to show you two different ways to distribute. One of them, a lot of you have probably seen. I bet you when I show you, it's going to jog your memory. You're going to be like, oh yeah, I've seen this before. And then the other way is probably going to be a little bit new. Okay, and fair warning, a lot of you are going to resist the second way that I show you because you're like, I already know the other way and that looks like it's more work. But I need you to understand the second way because we are going to have to use the second way when we get to some more complicated problems. Okay. All right. So, per day. Let's work through this. We're going to work through this problem two different times in two different ways. So let's write it down. 6 parentheses, negative 3x plus 2. So the first way we're going to work through this is the way that probably most of you have already seen this. Are we taking some notes here? It's up here. It needs to be in your notebook, please. So what most of you have seen with distribution is the idea that you take that number that's in front of the parenthesis and you multiply it by everything on the inside. And a lot of people will draw this little kind of rainbow thing above it. Does that look familiar to some of you? So I'm seeing a lot more people shake their heads now that you've seen that. That's distributing. So I just have to do 2 multiplication problems, basically. So let's do the 6 times the negative 3x. What's 6 times negative 3? Negative 18, and there's an x there, so we'll put an x here as well. So negative 18x. So that took care of 6 times the negative 3. We also have to do the 6 times the 2. What's 6 times 2? Is 12. Now there's got to be something in between these, and that's a positive 12, so I'm going to put a plus. If it had been a negative 12, I would have written a minus, but that's a positive 12, so I'm going to put a plus. And that's it. That's our answer. Does that look familiar? All right. I want to show you a slightly different way to look at this. And again, some of you are going to resist this because you're like, I already know how to do it the other way, but I need you to learn this way because we're going to need this for some more complex problems in just a moment. It's sitting right here. Go ahead and grab it on your way out. I'm recording, so you'll be able to watch the notes later. All right, so here's the other way. What we're going to end up doing is making a box. And my box needs to be, whatever this first thing is, that's how tall my box is going to be. And it's not going to be 6, it's going to be 1, because there's only one thing here. So I'm going to make a box that's 1 tall, and it's going to be 2 wide. So it needs to be a little bit wider than it is tall. There's my box. The number that's out in front here, the 6, goes in front of the box. Can you put that away? Thank you. And then these 2 things are going to go underneath them. I'm going to separate them. One of them is negative 3x, and one of them is positive 2. So I'm kind of splitting them apart, and they're becoming their own things here. Now, to find our final answer, all we have to do is multiply. This is like those old school multiplication tables. How many of you have stressful memories of elementary school where your teacher gave you a big grid and had like 3, 5, 8, 7, and down here was like 1, 6, 2, 4, and you had to go through and multiply them? Did anybody have to do this in elementary school? Like 1 times 3 is 3, 1 times 5 is 5, 6 times 3 is 18, 6 times 5 is 30, 6 times 8 is 48, right? Does anybody remember having to do something like that? Yeah. Oh, you had to add the two? So you've seen something like this, a grid like this before, where you take the number off to the side and the number up above, and you either add or you multiply. I have stressful memories of this because it was always timed, right? You got 30 seconds, 30 second go, and then you had to get as much done in 30 seconds. And did you guys have that as well? Maybe they're not so mean down it. Oh, it sounds like they are bees. It's not mean. It's good practice, right? But it was super stressful when they were like, 30 seconds. Anyways, this is the same idea. We're going to do the same thing. We're just going to multiply. So whatever's off to the side and whatever's down below. So 6 times negative 3x is negative 18x. You've done the box before? Oh, awesome. Oh, cool. That's awesome. But you probably didn't have x's and stuff in it, right? Okay. All right. So you've seen this before. We're just going to kind of make it a high school level by putting some variables and bigger numbers, some positives and negatives. Cool. All right. So 6 times 2 is 12. And then whatever's on the inside there, that becomes our final answer, which we already found. All right. So I'm going to ask you guys, as we do these problems, to try and use the box method, because we're going to expand this box and make it a little bit bigger. Now, before we move on, I want to label our two things. The thing that we started with here and the thing that we ended with. One of these is a product and one of them is a sum. Does anybody want to guess which one is the sum? What do you think, the first or the second? The second one's the sum because there's a plus in between them. You're absolutely right. The second one is the sum. We're adding a bunch of stuff together. And this one is the product. Do you see why it's the product? Because we're multiplying some things together. This is the product. So our whole learning target for today is to be able to take a product and turn it into a sum. We're going to do this using the box. Now, the reason I want you to do this using the box, even though some of you are going to convince yourself, oh, I can do this without the box. Here's the reason, okay? Let me give you the reason now so that you believe me on this. Before we leave today, we're going to do a box that's 2 rows high and 3 columns wide, okay? And you're not going to be able to pull that off by distributing, okay? And if you try and do it without the box, you're going to make a bunch of mistakes, and that's going to cause problems. So, all right, so that's why I want you to do it with the box. So let's do part B. And rather than distributing with the little rainbow arcs, we're going to use the box to do it. So part B, let's write down our original. It was x squared on the outside, parentheses, 4x minus 2y. And let's go ahead and label that. Is that a product or a sum? That's a product. I'm multiplying things together, so that's a product. We're going to turn that into a sum, something that it's equal to. We're going to do that by creating a box. Now, there's one thing here, so our box is only going to be 1 square high. There's 2 things in here, so our box needs to be 2 squares wide. Can you guys draw that box for me? Take the one thing and put it off to the left. So that's x squared. And take the 2 things and put them down below, 4x, and split them up. This is negative 2y. All right, and I am going to encourage you when you're doing these, if you have an x or a y or a z or a w or whatever that does not have an exponent on it, go ahead and put an exponent onto it. I'm going to put a 1 on this x here and a 1 on this y here. All right, let's do this. We're going to multiply this times this. So I'm going to put a 1 in front of that also. So the numbers in the front just multiply. 1 times 4 is 4. Let's see how we're doing with our exponent rules. What am I going to get when I multiply x to the second times x to the first? What am I going to do with those exponents? We're going to add the exponents together. Remember, we multiply two things together, which is what we're doing. We add the exponents. So we're going to have x to the 2 plus 1 gives us 3. So this would be x to the third. Now let's multiply these two things together. Start with your coefficients. 1 times -2 is -2. Is there another x for me to multiply this x squared by? Nope, so it just stays x squared. And there's no y for me to multiply this y to the first by, so it's just going to stay y to the first. So when I multiply these together, because the x and the y don't match, I don't want to add my exponents. We're just going to include both of them inside here. Final answer. 4x to the third minus 2x squared y. And I left the 1 off of the y in my final answer because it's not necessary. Usually if it's a 1, we don't include it in our final answer. So we've turned our product into a sum. Question. Why would we not subtract these? That is a wonderful question. Thank you for that. What a great question. Why would we not combine these two things together? Does anybody know the answer to that? It's a fantastic question. So in order to combine, so you're thinking of combining like terms. And I love that you're thinking about that because that is going to come into play in a later problem. So keep that in mind. We can only combine like terms if they have the exact same variables with the exact same exponents. That's the rule for like terms. So this one has an x. This also has an x, but this has a y. When I look at this, there are two terms here, right? We can only combine them if those terms both have the exact same variables and the exact same exponents. So do you see why we can't combine these together? The exponents don't match on the x, for one. And this one has a y and this one doesn't have. Now, if that had been 2x to the third instead, without the y there, then we would combine them together. So in order to combine things, they got to have the same variables with the same exponents. Super glad you asked that. Thank you for that question. Any other questions on that one before I move on? All right. So I'm going to ask you guys to do part C and D on your own right now. And I'll go ahead and write them down. I know it's kind of a pain to have the book open on your desk, so I'll write them down up here. C has t's in it. I'm going to change. We'll deal with it. We can deal with it. 5t parenthesis 10 minus 3t. And D is, oh my goodness, negative 4w parenthesis 8 minus 6k squared plus y. Wow, that's going to be awesome. And your goal is to turn those two products into sums. So make sure you set up your rectangle. I want to see your rectangles on these. I'm going to give you a little bit of a hint on D. What's going to be different about our rectangle for D? There's three things on the inside. There's only one thing out front. So it's going to be 1 square tall, but it's going to be 3 squares wide. All right, go ahead and work those out. I'm going to come around and check and see how you're doing. Let me know if you got questions. All right, let's see how we're going here. I've seen some really good habits that you guys are already adopting, and it really makes me happy. So I'm going to work through this one. This has got a 5t in front, and I saw a lot of you are putting that exponent of 1 on there. I think that's smart. That keeps me from making a mistake. The 10's going to go here and a negative 3t here. And again, I'm going to put that exponent of 1 on there. When we multiply, we should be getting 5 times 10 is 50, and t to the first. And here we've got 5 times negative 3 is negative 15. And I saw a couple of you just had t here because you didn't put the 1s on it, but you were able to fix your mistake. If you made that mistake, that's okay, right? Learn from it. This will be the last time you make it. If we put these 1s on here, the rule says we have to add 1 plus 1 to get a new exponent of 2. So that should have been negative 15t to the second. So my final answer, my sum would be 50t to the first. I'm not going to write the 1 in my final answer. And then minus 15t to the second. And I know some of you might be tempted to combine those together, but why can we not combine them together? Because the exponents are different. And again, thank you for that question. So exponents do not match, so we cannot combine them. So that's it. That's our final answer there. How many people were able to get that successfully? 50t minus 15t squared. With your help. Awesome. Awesome, awesome. All right, let's check this next one. I'm going to put a negative 4w up front, and I'll go ahead and put my exponent on there of 1. This is an 8. This is a negative 6k squared. That's already got an exponent, so I'll leave that be. And then we've got a y that would have an exponent of 1 also. Now I notice already that I don't have any w's down here. So I'm not going to be kind of combining w's together. It looks like we're going to have a whole bunch of different variables in our final answer. Let's just work through. So use the numbers first. Negative 4 times 8 is negative 32. I don't know why I'm second guessing myself. That's correct though, isn't it? And then there's a w to the first. There's nothing else to combine that with, so it stays. I'm going to have to write really small here. Negative times a negative is going to turn this one positive, isn't it? 6 times 4 is 24. And then this w and the k don't match, so we'll just bring them both into the box. W to the first, k to the second. And I should put a 1 in front of this y so that I can deal with the numbers up front first. So negative 4 times 1 is negative 4. And then again, we got a w to the first and a y to the first. Since those don't match, we'll just put them both in. Can't really bring them together because they don't match. So our final answer here is a pretty messy final answer, but I think we did it right. Negative 32w. Now that's a positive 24, so we need a plus here. Plus 24w k squared. And that's a negative, so we'll go minus 4w y. And that will be our final answer there. That one was pretty tricky. How many people were able to get that one? Oh my goodness. Oh, that's fantastic. And if you made a little mistake, are you seeing where your mistakes were? Right. All right, you guys ready to graduate to the real pro ones?
No. No.
You got this. You got this. I believe in you. All right, we're gonna skip to the next page. So put that page over. We're on 116 now. And I'm going to write up the first problem. So again, if you want to set your book to the side right now so you don't have it in your way. So page 116. We're going to do number 68. And we're going to work through parts A and B together, just like we did. I'm going to have you do C and D, and then we're going to be done for the day. You guys are doing great. Stick with me here. Oh, you got this. Parentheses, x plus 5, parentheses, 3x plus 2. Bless you. All right. If you were feeling okay about what we did a second ago, let's get that fun away, please. Thank you. Then you're gonna do just fine with this. So my goal is to write this as a sum. All right. Now, when I draw my box, Do you see what's going to be different this time? I got two things here. I got two terms and two terms here. So when I draw my box, it needs to be 2 squares tall and 2 squares wide. There's like 4 squares, yeah. Do you see why it has to be 2 squares tall this time, though? Because it's not just one term being multiplied out in front. And before we just had one thing out in front, but now we've got two things out in front. So when I set this up, I'm going to have an X and a 5 on the left-hand side. And I'm going to use those good habits that you guys were showing me and put some 1s on that X. Exponent of 1 and a coefficient of 1. What do you suppose I'm going to put across the bottom here? A 3x and a 2. So the thing that makes these the pro level ones is basically you just got twice as much work to do. Instead of multiplying to get 2 different answers, we got to get 4 different answers. Was there a question before we go on? You want to put you would rather have the 3x and the 2 on the top? That's totally fine. The book puts them on the bottom. I actually usually put them on the top as well. I'm being consistent with how the book does it. So yeah, the question was, could I put the 3x plus 2 across the top instead of across the bottom? If that makes more sense to you, then that's totally fine. You're going to end up with the same answer. All right, let's put a 1 on this x. Okay, so let's multiply. So this one is going to be 1x times 3x. So do the 1 times 3 first. 1 times 3 is 3. And what's x to the first times x to the first? X to the second. All right, I'm going to go to this square next. I got 1x times 2. 1 times 2 is 2. And I got x to the first there. Nothing to multiply with that with, so it's just 2x to the first. Moving down to the bottom left, I'm going to be doing 5 times 3x. 5 times 3 is 15, and I do have an x to the first that needs to go in there. And our last square here is going to be 5 times 2. That's easy. That's just 10. No variables there. All right, I want to go back to our excellent question a little while ago about like terms. Remember, like terms have the same variables with the same exponents. On the inside of my box here, do you see any like terms? Do you see them? Go ahead and put a little circle around those like terms. Because when we write our final answer, we're going to combine those together. So when we write our final answer, let's start with the biggest exponents. We've got 3x to the second. That doesn't combine with anything. What am I going to get when I combine these together? We're just adding them together because they're both positive. So positive 15x plus 2x is going to give us how many x's? 17. That's 17. And the exponents don't change when we combine them. So that's x to the first. And I have to put some sign here. It's positive 17, wasn't it? So let's put a plus in front of it. And then all we have left over here is that 10. And it's also positive, so I'll put a plus in front of it. And that's it. That's our final answer. 3x squared plus 17x plus 10. Do you see where the 17x is coming from? What do you think? A minute ago, there were some moans and groans when I said let's go to the pro level. Is this really that much difficult than what we were just doing? Just a little bit more work, right? All right, so let's do B, and then I'm going to challenge you to do D. If you're feeling good about this, go ahead and work B on your own. I'll write it down here. But if you can ignore me and go ahead and work it on your own. It's 2y minus 5 and then 5y plus 7. I'll tell you, if you are working this on your own, just be careful. You are going to have some negatives to deal with, so watch your signs. So try and do as much as you can on your own. I am going to work out my solution slowly up here, and you can look up here for a hint if you need to. But try and do as much on your own. You're going to be way better off actually doing the problem than just copying my work. And if you finish with B, go ahead and try D. I'll write that up here as well. D is more algebra 2 level, but I bet some of you are going to be able to get it, no problem. Oh, 14 minus 25. 13 minus 25. Negative what? Negative 11? Negative 11. 14 minus 2. Yeah, I don't know. I'm second guessing my mental math today. It's good on days like this to have a calculator handy, just to make you feel more confident. Yeah, okay. It's y, so that doesn't change, and then minus 3. So I've got my answer for part B up here. Go ahead and give that a look if you're finished and check and see how you did. If you're matching me, that's fantastic. If you're not, you go to small mistakes someplace, see if you can find it or get my attention. I can help you out. I'd like you to try D, give it a shot. I'll give you a hint when you do D. Yeah, I'll draw the box for D. So I've got two things here. So it needs to be 2 squares tall and it needs to be 3 squares wide. So we're actually going to end up with 6 squares altogether inside. 2 tall and 3 wide. So there's something that comes a little tricky with not part D. I'm going to give you a little hint here if you're working on this. When you've got two variables that end up in your same box, put them in alphabetical order. Okay, put them in alphabetical order. It's not necessary, but it's going to help keep you from making a mistake. So get in the habit of doing that. So when I did this box, I could have written it as 5WP, but I wrote it as 5PW. It's got a W, it's got a P. P comes before W in the alphabet, so I'm going to put the P first. If you get in the habit of always putting them in alphabetical order, it's going to help you catch like terms better. Woohoo! That is a beautiful answer. They snuck an algebra 2 problem here. I'll tell you what, if anybody's getting that correct answer for part D, then you got this down. You got it? That's awesome. That's awesome. Seriously, that's not an algebra 1 problem. That's an algebra 2 level problem. All right, as you're wrapping up, I just want to wrap up our class. We're working on products and sums today by making a box. It seems like everybody's got the basic idea of it. You can tell some of these problems get really nasty and messy because some of the boxes end up with 6 inside instead of 4 or 2. But it's all basically the same thing. Our homework assignment is going to be from, you got it as well? Nicely done. You got it? We got it. Several people who got it. Who else got it? Anybody else? Oh my gosh, that's like half the class. That is really impressive. Well done, guys. Our homework assignment is due on Friday. It's from 3.2.4. So again, we're skipping a couple sections. Folks, if you're feeling not super confident about this, and if you're not feeling super confident about exponents either, we're going to be practicing them a whole bunch on Friday. Okay, so expect Friday's nothing new. And you guys have been great today and Monday. We've had some long notes. I appreciate you sticking with me. Friday, you're going to have the period to work. Okay, so I'm not going to be talking at you. You'll get a chance to work with a partner and just practice this stuff. Thank you so much for your attention. Let me know if you got questions.